Very similar to section 2.5 with addition and subtraction, 2.6 uses arithmetic properties, this time multiplication and division properties. The first theorem in this section is number 14. If segments or angles are congruent, then they're like multiples are congruent. Very similar to that is theorem 15. If segments, angles are congruent, then they're like divisions are congruent. When using these theorems, a couple of things usually occur. Usually, we're given something like AB is congruent to DB. So we're given some kind of congruency of the segments to begin with. The second thing that's usually important to kind of note is that we're usually given a note about a midpoint or a trisection point. In this case, we'll say that B is a midpoint, as is E is a midpoint. What that does is it kind of establishes that there's more congruency within the segments without actually saying it. Since that happens and you know it's going to be even throughout the segments, then what you can say is the like multiple, because you're going from a smaller unit of congruency to a larger. You would use the division theorem kind of the opposite way. Still, given that B and E are midpoints, usually what happens is you're given the larger segments are congruent, but then you're asked to prove the smaller segments incongruent. And again, if you know the larger segments are congruent, and knowing that they're midpoints, you know that their halves are then going to be congruent to each other. If we look at example number 5 on page 92, we're given the following, that segment JK is congruent to MK, and line OP bisects JK and MK. Also given the following diagram of a triangle being bisected. Again, when starting off with proofs, I would suggest you always start out with the givens. JK equals MK, line OP bisects JK and MK. From there, we'll take a look at the given, and specifically the one that bisects JK and MK. Since we know that it bisects, we know that it divides it into two different parts. So since it bisects JK, we know that JO and OK will be congruent, but also MP and PK will be congruent. And that is because of the definition of bisecting. If a line bisects a segment, then it creates two congruent segments. Now we can go to the conclusion that JO is congruent to PK. The reason that we know this is, again, we kind of established some congruencies here with the larger segments, and we know that it's bisected and that those smaller segments are going to be congruent. So our reasoning can be, if segments are congruent, then their like divisions are also congruent.